theta 0. So for these parameters, I have to find out the values of these parameters such that the error j theta is minimum. This is the objective. Okay. So we have defined, if you remember, we have defined this problem mathematically like arguments theta 1, theta 0, you have to find out such that whatever there in the bracket should be minimized. And what is there in the bracket? It is half MSE. The error between y and y cap. Okay. Of course, it is squared error. And this is the problem that we define. So mathematical definition for our problem is this. So how do we do for this? So the problem is, first we have to find out the gradient. So start with some values of parameters. So let us say theta 0 and theta 1. Now in the previous example, we have taken theta 0 as 0. That is y-intercept we have considered as 0. So this is the model. Y cap is equal to theta 1 x. Okay, into say theta 0. Or let's say the variable is say x1. Okay, try to understand this is a univariate system because there is only one variable, only one uh, feature. Okay, and these are the parameters of the model. This is bias and this is weight. Okay, theta 1 is a weight, theta 0 we call it as a bias, right? Similar equation in terms of the weights we can write as W1x plus B. B stands for bias. So don't get confused with the notations, they are almost same. So that if I simplify the model further by taking bias value as 0, my model will be simply y cap is equal to theta 1 x. So I have only one parameter, right? So if I have only one parameter and if I plot this j theta 1 as a function of theta 1, I'll get this bowl shaped curve. Okay. So if I right now, if I initiate my model with some theta 1 value and say theta 1 is say 2. So last time we did this exercise. Okay, we did this exercise. What happens with theta 1 is equal to 2? What happens with theta is equal to 0? Okay, and at theta 1 is equal to 1, you are going to get the exact value. Okay. So how do I do this basically, or how do I write the steps in the algorithm? So start with some values of parameters, initial values, and estimate j theta. Okay. Once I estimate the j theta, this is the definition of j theta. So find out j theta, then find out the gradient. Okay. Find out the gradient. We'll talk about this, how to find out this gradient. After finding out the gradient, update the theta 0 and theta 1, and these are the equations. So how do I update the theta values? This is the standard equation. Okay. What this equation tells us? The current update theta j, like j is the j runs from 0 to those many parameters like theta 0, theta 1, theta 2, theta 3, w0, w1, w2, w3, all these are parameters. So new value of the parameter is equal to the old value of the parameter minus alpha, which is learning rate. Okay, here alpha is learning rate. I will talk about this learning rate little later. Into gradient. Into gradient. Now this update equation is valid when you are traveling from this side to this side. I mean, if your previous value of theta is greater than the current value, then the sign is negative. But suppose I am starting my algorithm from this side, okay? So I have to increase the value of theta. Try to understand. If I have to reach to this value, this is our target. This is our target where theta 1 becomes 1. And right now I am at theta 1 is equal to 2. So whatever the gradient that I estimate, that has to be subtracted so that I will reach to this point. Whereas if I have the if I have the values initiated, let's say theta 1 is equal to 0, where this 0 is smaller than the actual target value, okay? So I have to go on incrementing, and that's why this equation will become theta j is equal to theta j plus alpha into this gradient, okay? So hope this point is clear. So let me clear all those things. So this is the update equation. So first you are initiating the theta 0, theta 1 values, finding out the gradients, finding out the updates, okay? And go on updating the values of the parameters, okay? And every time what you are doing, every time you are finding out j theta. So where to stop? You have to decide a stopping criteria. That means, let's say j theta, whenever you get this value less than or equal to, okay, say 0.01, okay, you can stop. So when you actually your error get reduced to 0.01, then you are going to stop the algorithm. So this is the iterative process, okay? So this is going to be repeated, right? Any doubt till this? Yes, all of you, quickly. Got the update equation?
Yes, sir.
Yeah. So when it becomes multivariate, I will talk about multivariate. I mean, if you have more than one variable, how this bowl shape. So this is two-dimensional because you have only one parameter, okay? But if you have equation like this, say y cap is equal to theta 1 x1, let's say theta 2 x2. So you have got two features, no? So if you have got two features like x1 and x2, okay, and for this if I have to plot the error function, then this will be a 3D plot. This will be 3D plot, and that's why visualization becomes very complex if I go on adding the features like x3 x4. So this will become 4-dimensional plot, 5-dimensional, and so on and so forth. Okay, so this slide is just explaining that how your the error function will become complex and complex to visualize, okay, if you go on increasing the number of features, okay? And that's why you have to have a proper features, optimized features, and that's why we need a techniques called as feature reduction. So we are going to see that. Okay. Now going further, and this is very important point, how do I differentiate and find out the gradients? So if I consider a model, very simple model, line model, theta 1 x plus theta 0. So for this model, I have to estimate the parameters theta 1, theta 0. So this is my problem, such that j theta will be as minimum as possible. This is the target. This is our object. For that, we are finding out the gradient. Okay. Now gradient of theta 1 with respect to theta 1 and theta 0 with respect to theta 0. So for this model, if I have to update theta 1, what will be my equation? Look at this equation. Okay. So update equation we have seen theta j. So theta 0. Okay. So new value of theta 0 will be old value minus learning rate dj theta 0 divided by d theta 0. Similarly, for theta 1, I have to write as theta 1 minus alpha dj theta 1 with respect